Hi everyone, welcome to today's GATE session. Myself Valarmathi, working as an assistant professor in Department of Information Technology. Today I'm going to see about the topic as Ethernet bridging in computer networks. First we'll see what is bridging in Ethernet. Bridging is a device which is used to connect two or more devices, that is two or more networks of different types. It may be a mesh topology, or you can say it as a token ring or Ethernet. These are connected using the bridges. It works in the physical layer as well as in the data link layer. You can say it as a data link layer device. Consider this diagram. In this, the bridge is marked as a B1 and bridge is taken as a B2. And this bridge B1 is connected with the LAN 1. This is port 1. This one is considered as port 2. This A and B are station, or we can say it as a PC, or we can say it as the host machines. Similarly, the port 1 is connected with the AB in the LAN 1 and the P1 is connected with the port 2 through a LAN 2. Next, we'll see the bridge 2. The bridge 2 contains three ports, port 1, port 2 and port 3. The port 1 of a B2 is connected with the port 2 of B1. Next, here you'll see the LAN 4. In this LAN 4, you have three PCs. This one is the first station, second station 1, station 2 and then station 3. Here D and C, D and E are the station of the LAN 3. Next, we'll see about the network bridge. Network bridge, it is a device that divides the network into segments. For example, here the bridge which contains the port 1 and then port 2. In this port 1 is connected to the LAN, which contains A, B, C host machines. These machines are taken as these machines, we can say it as a segment. Increase the performance by reducing the collisions. Next, we'll see types of bridges. In this, we have two types of bridges, static bridges and then dynamic bridges. Static bridges, which is said to be the entries in the mapping tables are added dynamically. That means added by the users manually. So, we can say it as a static bridge. Dynamic bridge means the entries in the mapping tables are automatically added by learning and updating on the mapping table. You can see here the map tables, which is formed based on the connectivity of the host machines with the bridge. Which machine is connected to which port, belongs to which port, and then which bridge it is connected. The bridge will observe the MAC address of the machine. Consider the MAC address of the most machine is A. For this belongs to port 1. So I can mention it as a port 1, it belongs to A. The machine P, which belongs to port 1. The machine C, it also belongs to port 1. Similarly, the machine D, which belongs to port 2. These details will be based using this mapping table. If the mapping table is used for a static and dynamic bridges, if it is entered automatically, we can say it as a dynamic bridge, or we can say it as a learning bridge or a transparent bridge. If you have a small type of networks, at the time you can go for static bridge. If it is a more number of networks, more systems are connected, at the time it is better to use the dynamic bridge. Next, we will see capabilities of bridge. In this, we have 4 capabilities: filtering, forwarding, flooding, and then store and forward. Filtering. Filtering is, instead of forwarding the packet, if it's first, the bridge will observe whether the MAC address, that is the source MAC address and the destination MAC address, which belongs to the same lane, then it will just filter and send the message to the destination instead of forwarding. Whereas in forwarding, it will check if the source MAC address and destination MAC address belongs to different LAN. At the time, it will forward. Flooding. Suppose if new host machine is added, it will not know which host machine is added right now. So at that time we can use the flooding. Flooding will transfer the packets to the currently added host machine. Store and forward. Store and forward is used to avoid the collisions. If more than one host machine transfers the packets, in order to avoid the collisions, it will store the packets sent one by one. So we can use the store and forward in Ethernet bridge. Next, we'll see in detail filtering. If any bridge finds that source MAC address and destination MAC address are on same line, then it will not forward it and will simply filter it. See here, I'm choosing an source MAC address as A and destination MAC address as B. It will directly send the message from A to B by simply filtering instead of forwarding. Filter and send the message to B. Next, forwarding. If any bridge finds that source MAC address and destination MAC address are on different sides of lane, then it will sit as forwarding. If I want to send message or packets from A to P, it will check, the bridge will observe the MAC address of A, where which port it belongs to. The MAC address of B belongs to which ports. Identifies a port. Both are in different port, so it will forward the message from A to P. Next, flooding. If a new station is added, the bridge doesn't know about it, then flood will be done in order to see the packets to the newly arrived mission station. In order to, if a new packet is added, the bridge will not exactly know where it is. In order to avoid that, the flooding concept is used here. The flood will identify the packets to the newly added missions. Store and forward. No collision inside a bridge. Bridge will store the packets, and whenever it will convert for bridge, then it will going to forward it. Here, A wants to send packet to B, R wants to send packet to C. At the time, A is a source mission. It transfer packets to P, destination mission. Simultaneously, R is a source mission. Transfer packet to the destination mission C. At the time, the bridge will stores the packet, any one of the packet. It may be A to P or R to C. It holds any one of them. It's transferred one by one in order to avoid the collisions. These are the capabilities of bridge. Next, you will see the spanning tree algorithm. Spanning tree is same as a data structure what we studied. In order to avoid this cyclic formation, step 1, every bridge has a built-in ID. The one with smallest ID will be taken as a root bridge. Next slide, I will see the diagram. In this diagram, I have the 5 bridges. In these 5 bridges, I have taken B1 as the smallest bridge. So, I am taking B1 as the root bridge. Taking the root bridge example B1. Mark one port of each bridge as a root port which is closest to the root bridge. The port which is first, we have to find the root bridge. Based on the root bridge, we have to calculate the root port. The port which is closest to the root bridge, based on this, we can calculate. Every LAN has chooses a bridge closest to it as a designated bridge for that LAN. Make that correspondent port has a designated port. Next, we will calculate after calculating the root port, we will calculate the designated port. It is based on the LAN, which is the bridge which is closest to the LAN will be taken as a root port, designated port. Mark the root port and designation port as a forwarding port, block the remaining port. Here, the one which is does not used, so we can mark that as a block the port. Here, the cycling problem of bridge is resolved by the spanning tree. Take this diagram. In this diagram, the bridge 1 is connected with the LAN 1 and bridge 2 is also connected with the LAN 1. Then bridge 3 is connected with LAN 2, LAN 4 and then LAN 3. Bridge 4 is connected to LAN 2 and then LAN 4. Bridge 5 is connected with LAN 3 and then LAN 4. According to this, I am taking the smallest value or lowest indexes B1. So, it is considered as a root bridge. Based on this, we are going to calculate the root port and the designated port. Here, root port. Here, for this, everyone I marked as a number as port 1, port 2. For this one, port 1, port 2. For B3, port 1, port 2, port 3. B4 has 2 port 1, port 2. B5 has port 2 port 1, port 2. In this, B1 is taken as a root bridge. So, we should not consider root port for B1. Based on this B1 only, we are going to calculate the root port. So, apart from that B1, we have to calculate root port for B2, B3, B4, B5. In this B2, root port is, we will calculate it. Here it has 2 port, 1 and the 2. In this 1, it will directly connect to the B1. So, we can take B1 as a root port. If I take 2 means, port 2 means, it will take 2 hops. It can reach to B3, from B3 to it can reach the B1. Based on the root node only we can calculate. This one is the root bridge. Based on this only we can calculate. Next we will take the B3. In this B3 I have 3 ports, port 1, port 2, port 3. If I take in port 1 means it will directly connect to the root bridge. So I can choose this one as the root port. If I take 2 means it will take 2 hops, B3 to B2, B2 to B1. It will take 2 hops. For a B3 means it also take 2 hops, B3 to B4, 3 means B3 to B4, B4 to B1. Again it take 2 hops. So compared to 1, 2, 3, 1 is the root port. Next I am checking the B4. In this B4 it has 1 and 2, port 1, port 2. The port 1 means it will directly connected to B1, so I am taking this one as the root port. B2 means it will take B4 to B3, B3 to B1 2 hops, or B4 to B5, B5 to B3 and then B4 means 3 hops, or B4 to B5, B5 to B2 and then B1 it will take 3 hops. So I am taking root port as B1. Based on the hops we will choose the root port. Once the root port is chosen, next we will move to the step 3 designated port. It is selected based on the LAN. And this LAN 1 is connected to bridge 1 and then bridge 2. See here in this LAN 1, bridge 1 and bridge 2 is connected. Here we will consider the root bridge. We will give preference to the bridge which is the lowest indices. Compared to B2, B1 is lower, so we are giving preference to B1. Next I am choosing the LAN 2. And this LAN 2 is connected with B1, B3 and B4. B1, B3, B4. B1 is the smallest, so I am taking B1 as the designated port. Next we will see the LAN 3. In this LAN 3, B2, B3, B5 is connected. Next we will see in this 3 are connected. Compared to B2, B3, B5, B2 is the lowest indices, so I am choosing B2 as the designated port. Next one is LAN 4. In this LAN 4, B3, B4, B5 is connected, where B3 is the smallest indices, lowest indices, so we can take B3 as the designation port. Once the designation port are chosen and the root ports are chosen, we will remove the remaining ports which are not connected. That is, mark the root port and designation port and remove the remaining parts, and remove the parts from B3 to lane 3, lane 3 to B5 and then lane 4 to B4. These parts are not used, so I removed our blocks. Now the cyclic is transformed into a spanning tree structure. Next we'll move to the questions. In these questions, consider the diagram shown below where a number of LANs are connected by transparent bridges. In order to avoid packets looping through circuits in the graph, the bridges organize themselves in a spanning tree. First, the root bridge is identified as the bridge with the least serial number. Next, the root sends out one or more data units to enable the setting up of the spanning tree of shortest path from the root bridge to each bridge. Each bridge identifies a port, the root port, which is we calculate in the step 2, through which it will forward the frames to the root port. Port conflicts are always resolved in favor of the port with the lower indices values. Lower indices values we will take in the B1, which one is a value contains lower value. We take that as a lower indices value. Then there is a possibility of multiple bridges forwarding to the same LAN, but not through the root port. Ties are broken as follows. Bridges closest to the root, we get preference. The bridges which is closest to the root, or that is root means we will choose the lower indices value, that is the closest to the root, get preference, and between such bridges the one with the lowest serial number is preferred. For the given collection of LANs by bridges, which one of the following choices represents the depth first traversal of the spanning tree of bridges? Here the options given as A, B, C, D, A, B, D, C, A, C, B, D, A, C, D, B. First I am taking the root port, root bridge, that is because A contains the value as the smallest value compared to B, bridge C and the bridge D. A has the lowest indexes, so I am choosing it as a root bridge. After once the root bridge is chosen, based on this we will calculate the root port. Root port is identified by the bridge which is closest to the, in this we have port 1, port 2, port 3 in this bridge. The which port is closest to the root bridge? Here the 1 is closest to root bridge, so I mark this as a root port. Next, we move to the bridge C. In this bridge C, I am having two ports, 1, 2, 3. Which one port is closest to the root bridge? Then here we choose port 1 is closest to the root bridge. Next, we will take the bridge D. In this, we have two ports, 1 and 2. So here we have to choose which port is closest to the root bridge. Here it will take 1 hop and 2 hop. Here also it will take 1 hop and 2 hop. But the value compared to B and C, the value of the bridge B is 3050, and the value of the C is 50010. The value of the bridge 3050 is the lowest indices, so I am choosing this as the root port. The output of this planning graph is A, B, D, and then C. The answer is A, B, D, C. It is a depth first traversal. Next question. Consider the diagram shown below where a number of lands are connected by transparent bridges. Transparent bridges is nothing but the dynamic bridges. We already studied the types of bridges. In order to avoid the packets looping through circuits in the graph, the bridges organize themselves in a spanning tree. First, the root bridge is identified as the bridge with the least serial number. Root bridges, we taken the bridge with as the least serial number is the root bridge. Next, the root sends out one or more data units to enable the setting up of the spanning tree of shortest path from the root bridging. From this root bridging, you have to find the shortest path. To each bridge identifies the port, the root port, through which it will forward the frames to the root bridge. We have to identify the root bridge and then root port, through which it will forward the frames to the root bridge. Port conflicts are always resolved in the favor of the port with the lower indexes value when there is a possibility of multiple bridges forwarding the same length but not through the root port. Ties are broken as follows. Bridges closest to the root get preferred, and between such bridges, the one with the lowest serial number is preferred. Here, the graph is given as 5 bridges: bridge 1, bridge 2, bridge 3, bridge 4, and then bridge 5. These are connected with the lane 1, lane 2, lane 3, lane 4, and then lane 5, lane 6. 6 lanes are connected. The host missions between the B1 and B5 are host 1, host 2, and then B1 to B3 are host 3, host 4. Next, we'll see B4 and B5 are host 5 and then host 6. B2 and B3 are connected with host 7 and then host 8. Last lane 5 is connected with the host 9 and host 10. Lane 6 is connected with host 11 and host 11. Nearly 12 host missions are connected with these 5 bridges. Here the port numbers are given already. We have to, based on this, which port we have to choose. First we have to choose this based on this spanning tree algorithm. First we will choose the root bridge. For the given connections of land by bridges, which one of the following choices represents the depth first traversal of the spanning tree of bridges? B1, B5, B3, B4, B2, or B1, B3, B5, B2, B4, B1, B5, B2, B3, B4, B1, B3, B4, B5, B2. For this, I must solve the answer. I am choosing the B1, which is the lowest indices. I am taking it as a root bridge. This is which we can calculate the root port. That is, apart from this root bridge, we have to calculate root port for B5, B4, B2, and then B3. First, I am taking the root port for B3. B3 is closest to the B3 contains 4 ports. First port is connected to LAN 3. This LAN 3, which is connected to LAN 3, and then second port is connected to LAN 4. In this, it will reach the bridge 1. It takes a less number of times. That is, it takes only 1 hops. B3 to B1 reaching directly. If I take the port 4, it will reach to B5 and then B1. It will take the B3. First port means it will take B5 to B1. Second port means it will take B2 to B1. So the number of hops takes only 1 hops, or you can say it has directly reached B1 if I choose the port 3. For a B5, it also directly connected to the B1, so it can take only 1 hop if the port is 2. If I port 1 means it will connect it to port B2 and then it will take 2 hops. If port 4 means it is connected to B4, it also takes 2 hops. Port 1 means it is directly connected and it is connected to B3, it takes 2 hops. B5 port 2 means it is directly connected, it takes only 1 hop. Next, we calculate for the bridge 4. In a bridge 4, which is closest path to the root bridge. That is, if I take B4, B4 to B5 or B1, or B4 to B3 or B1. Another one is directly connected to lane 3 ports. So I'm choosing this one as the first port as the root port for B4. Next, B2. B2, we have to calculate the root port. In a B2 also same manner, it contains 1, 2, 3 port. First port is connected to B3 and then B1. Second port is connected to B5 and then B1. So I am choosing directly 1 as a root port for this B2. Next, you calculate the designated port. Designated port is, for designated port, you can calculate the LAN. Here, they can mention it as a segment. This one is a segment 1, and then segment 2, segment 3, segment 4, segment 5, segment 6. Segments already we discussed in the network device. That is, network device, it divides the networks into segments. Here we can mention it as a 6 segments. In the segments, we have to include the root bridge also. Root bridge belongs to which segments? First, if the root bridge is the lowest index, so based on the LAN, in this LAN, they're connected with a 3-1, that is 3 bridges, B1, B5 and then B3. Compared to B1, B3, B5, B1 is the lowest indices, so it is directly taken it as a designated port. Whereas in segment 2, it is also connected with the B1, B5, B3, and this B1 as the lowest indices, so it can directly taken B2 second port as the designated port. Next, you will take the segment 3. In the segment 3, it is connected with the B5, B3, B4 and then B2. If I choose an B4 it is 2 hops it will take, whereas the B2 is also distance. So we can choose B3 or B5. Compared to B3, B5, B3 is the lowest indices, but is nearer to B1. So we can choose the B3 as the port, B3 as the designated port. See here, I am choosing B3 as a designated port. Similarly, we have to calculate for segment 4. And this segment 4, I am choosing, there is segment 4 which is connected with a B3, B5 and then B4, B2. Here the B2 and B4 are also far away. So I am taking the B3 or B5. Compared to B3 and B5, B3 is lower indices. So I am choosing designated port in B3. Next, S5 and then S6. Here, S5 segment 5, it is connected to only one port. So I have directly chosen that port as a designated port. S6 also connected to only one port. So I am directly chosen this port as a designated port. Once the designated port and the root ports are marked, the remaining ports which are not used are blocked ports, which is not to avoid the cycling, to get the spanning tree. See here, the red color indices, these ports are the blocked ports. These ports are not used. See, these ports are removed. After removing these ports, we will get the spanning tree. That is, B1 is connected with the B5 and then B3. B3 is connected with the B4 and then B2. We will get the spanning tree like this. B1, B5, B1 is B3, B4, B2. Thank you. That's all the questions. We will meet in the next session.